All right, so we are going to finish up our study of factoring, and this is like it. So I'm not going to surprise you with more kinds of factoring later in the school year. Like, this is it. We're done with factoring. Once you've done this, you've done everything you probably want to do for factoring for a while. There are some other things that we can look at with factoring, but we don't have to go there right now. So this is going to be the last of the special cases. And last class I gave you the list. We have like difference of squares, sum and difference of cubes, which is the soap sandwich, and then we have this factoring by grouping. Now, I mentioned that a lot of you have been using factoring by grouping to factor your trinomials. So what you've been doing is taking your trinomial and breaking the middle term up so that you actually get 4 terms. And so when you're using factoring by grouping, I want you to use this when you have 4 terms. Now, not everything that has 4 terms can be factored by grouping, but it's one of the things that you check. So just because like something has 2 terms doesn't mean that it's the difference of squares. And not every trinomial is factorable. So we know that not everything is factorable. This is just something that you check for to see if it can be factored. And I'm not going to throw you curveballs. I know in an honors class, sometimes the teacher will give you stuff that's not factorable, and that can be really, really frustrating because you can be trying to factor it and it doesn't factor. I am not going to do that to you. So if I give you something and say, like, factor this, or factor this by grouping, it will be doable. So I'm not going to throw you that kind of curveball. So here's the key idea. Let me get the key idea up there. So how this works is you're going to break the polynomial into 2 groups. You're going to break it into the first group and the second group. You're going to factor the first group using a GCF factoring. So I guess this strategy, you really only have to use greatest common factor. You're going to factor the first group using the greatest common factor. Then you're going to factor the second group using the greatest common factor. When you do that, you are going to see a new common factor, and then you're going to factor that out. So key idea, factor the first group, factor the second group, and then factor out the GCF. Now, on my notes, for some reason, I have a line drawn through one of the example problems, and I have absolutely no idea why. Maybe there was a good reason for it. We won't do that one first. We'll maybe do that one last as part of the adventure. So we have x to the third plus 5x squared minus 3x minus 15. So I want to draw your attention. Notice that this is a cubic polynomial expression. There's no equal sign in it. We're going to save the equal sign for a future lesson. It is a 3rd degree and it has 4 terms. 1, 2, 3, 4. So that's when you want to try this. You're going to try this when there's 4 terms. Now, if you're wondering, what is she talking about? Like, she's got groups. We are going to take these 2 and factor them as though they were the entire problem. So we're just going to look for a common factor. Then we're going to take these 2 and factor those with a GCF as though that was the entire problem. When we do that, we are going to see a common factor appear. So just looking at x to the third plus x to 5x squared. If we were in class, like what I would do is kind of put my hand or my finger over that part to kind of block it from your view. And I can't really do that in a video, so you're just going to have to pretend it's not there. If you were only factoring x cubed plus 5x squared, you would look for a GCF. And you'd say, oh, I've got 3 x's here and I have 2 x's here, so I have a common factor of x squared. And then you set up your parentheses. If you have 3 x's and you take 2 of them out, you are left with 1. If you have 5x squared and you take the x squared out, you are left with 5. Now we do the same thing over here. Whoa, don't do that. Okay. Okay, everything's saved. We look at the negative 3x minus 15. Now, this might get a little bit tricky, but here's what you're looking for. You're going to try to get x plus 5. as the factor that's left behind, and you can't do that with the negative sign there. So we're going to factor out like the negative. We're going to factor out like a -3. Okay. So factor out the -3. If you have -3x and you factor out the -3, you're left with the positive x. And if you have -15 and you factor out a -3, you will get +5. I'm just going to stop talking for a moment and let you write that down if you're doing the notes, which you should be, and think about it for a moment. Okay, and that's just to let you look at what you wrote down and rehearse that in your head a little bit. Like, okay, what did she do? Why did that minus sign turn to a plus sign? Just kind of get your head around what happened there. Now, as you notice this, and you can actually use this to help you do factoring by grouping, notice that you have an x plus 5 and an x plus 5. If it's going to work, you're going to get matching things in the parentheses. So what we have here is another common factor. You have x squared times x plus 5. And you have -3 times x plus 5. You have a factor of x squared, a factor of x plus 5. A factor of -3, a factor of x plus 5. So if I were to ask you, what do they have in common? Hopefully you would say, the x plus 5. They have an x plus 5 in common. And what do we do with the common factor? We factor it out. And so we're going to take that x plus 5 and we're going to factor it out. And then we ask ourselves, what's left over? Well, if you have x squared times x plus 5 and you take out the x plus 5, you're left with x squared. If you have -3 times x plus 5 and you factor out the x plus 5, you're left with -3. And then the last thing you want to do is just check and see if you're able to factor that further. Sometimes when you get to that step, you actually have the difference of squares. I think the next one is going to have that, and so you actually can do one more step there. Now that, of course, was the first example. That took us like a good 5 minutes to do. We're going to speed it up at this point now that you know that you kind of have an idea of what we're doing. So let's look at example 2. Example 2 is x to the third plus 6x squared minus 9x minus 54. And we're going to break this up into 2 groups. So we're going to get the x to the third plus 6x squared. And we look at that and say, what's the common factor? Well, we have 3 x's and we have 2 x's, so we can factor 2 of those x's out. If you have 3 x's and 2 of them come out, you are left with just 1. If you have 6x squared and the x squared comes out, you're left with the 6. And we have the similar deal over here where we have -9x minus 54. And we look at what's common. And again, you can kind of use this to help you. Like if it's going to work, you're going to get x plus 6. So like sometimes people will even do this. They'll even like put the x plus 6 here and then figure out what it is that they have to put here to get the x plus 6. Okay, that's actually a smart way to do it, as long as it works. So the common factor here is actually going to be the -9. 9 times 6 is the is 54. So we take out the -9, and if you have -9 times x and you take out the -9, you're left with x. If you have If you have -54 and you take out a -9, you are left with positive 6. Well, now we have, just kind of restructured it there. We have x squared times x plus 6, and we have -9 times x plus 6. And so we ask ourselves, what do we have in common? Well, we have an x plus 6. So let's factor it out. And we see what's left. If you have x squared times x plus 6, then you take out the x plus 6, then you are left with x squared. If you have -9 times x plus 6 and you take the x plus 6 out, you are left with -9. And now you just got to be really careful here. That is the difference of squares. X squared minus 9 matches that other special case, which factors into conjugates. And we get x plus 3 and x minus 3. And then, of course, we have the x plus 6. So don't forget the x plus 6. I don't like that last parenthesis. There we go. And now we're done with the factoring. Now, I do have one other example there, and for some reason, it's got a line through it, but I'm not sure why. So let's go ahead and do it, because why not? And maybe we'll figure out why. Oh, I don't want orange. Let's do purple. Why I drew a line through it. So we have x to the third minus 3x squared plus 4x minus 12. Now, these actually do get really, really, really messy, where you can have, a leading coefficient out here that you got to factor out. And mostly what I'm concerned about is that you learn the strategy and you learn the procedure. If you go further in math, and if that teacher wants to take factoring to the next level, then you can look at some of the more complicated versions. But at the end of this unit, if you could just know how this process works, then I'll consider it a successful lesson. So let's take a look at that first group. We have x to the third minus 3x squared, and of course we can factor an x squared out. Have x to the third, take out 2 of the x's, you're left with 1. And then we have 3x squared, we're going to take out 2 of the x's, and we're going to be left with the 3, or I guess the minus 3. Over here, 4x minus 12. Well, the common factor there is 4. If I take out 4 from 4x, I'll be left with an x. And if I factor out a 4 from the negative 12, I'll be left with negative 3. And our parentheses match. Now, if you do this and the parentheses don't match, either you have done something wrong or it's a strategy that doesn't work. No biggie. Now we have a common factor of x minus 3. Now you might be saying, okay, Ms. Taylor, every time you do this, one of the parentheses ends up being x minus 3 and the other parenthesis ends up being, whatever was left behind after you factored it out. Yes, that is true. And so if you want to say, okay, it's going to be x plus 3, and then the other parenthesis is going to be x squared plus 4, that's fine as long as you understand why. A lot of students get very uncomfortable with this because it looks like one of the x plus 3, x minus 3 in this case, it looks like one of them disappeared. Like in this line, you've got 2 of them, and now all of a sudden you have 1, and that really bothers a lot of students. Think of it this way. The 2 of them are still there because if you were to distribute the x minus 3 through, you'd have like x minus 3 times x squared, x minus 3 times 4, and then you'd get like the 2 x minus 3's back. All right, so last thing that we need to do is we need to give you guys a chance to practice it. And for some reason, I have an asterisk near one of these, so that will probably make you feel really good. Let me get the practice problems up on the screen here. Okay, here they are. Practice is fun if you're a math teacher, or maybe if you're a math student. I don't know. Maybe it's fun for you guys too. So practice is fun, but it's important. It's essential. So we do it anyway, whether it's fun or not. We have x to the third plus 4x squared plus 5x plus 20. Now, this is the one that has a little asterisk next to it, and I'm not sure why. At some point in my notes, I put a little star next to that for some reason. I don't know. Maybe it's hard. It's got some like weird stuff with the negative in there, so I'm thinking it probably has something to do with a minus sign. So just kind of heads up about that. You can handle it. You'll be fine. And if you mess it up, that's okay too. It's practice. And then the last one there is very similar to the last one I did. X to the third plus 3x squared minus 4x minus 12. Looks a lot like that one. I think we have a flipped plus and minus around there. I think. Okay, I don't know what I did. I paused recording. That was weird. Yeah, I think there's like a flipped plus and minus in that. Yeah, so there you go. And then at the bottom, there's just a little note like, why are we going through, more factoring? And just to tie it in with the previous lesson, this allows us to find more x-intercepts. So if you think back to the last lesson, our polynomials had to be in factored form in order to find the x-intercepts. but we know that not every polynomial is given to us in factored form, and so this allows us to get more polynomials into factored form so we can find those x-intercepts. And there's obviously like a lot more ways that you could factor. We could study polynomials all year and just kind of keep exploring things with them. All right, so I'll leave it at that and give you guys some time to practice, and then we'll go over it together. Okay, and I'm just realizing now that in the last video, I never put the answers to the practice problem in the video, which I always do if people are going to be looking at the videos later. And it's just occurring to me now that I didn't do that. So go me. Oops. All right, so this is the part that's for people that are watching the video after the fact for some additional review and so forth. So this first one, we factor the first group, we factor out an x squared, and you'll notice that most of these problems, like, we're just basically factoring out an x squared. I'm not putting other numbers in there or making that GCF factoring really complicated. And again, that's just because I want you to learn the technique and the skill, and if at some point in the future you have to expound on that and do more with it, you'll have the basics down. For the second part here, we've got 5x plus 20. So factor out the 5 and you get x plus 4. So now we have a common factor of x plus 4, and what's left over is the x squared plus 5. Does not matter what order you have those factors in. Second one, let's see if we can figure out why this one has an asterisk by it. I don't know. So we have, probably because when you factor out the x squared here, you're left with a 1. Remember this little ditty? When you take out everything, you're left with a 1. And that's probably going to give us a clue here. We're going to factor out a negative 2. And that's a little weird here with the pluses and the minuses. So let's just do a quick check. Negative 2 times x is negative 2x, and negative 2 times negative 1 is positive 2. So just did a little check there. Common factor is x minus 1, and you're left with x squared minus 2. And last one was x to the third plus 3x squared minus 4x minus 12. GCF in the first group is x squared, leaving us with x plus 3. GCF in the back group is negative 4, leaving us with x plus 3. Common factor is x plus 3. And then we have x squared minus 4. Oops, but we got to check. And that is a difference of two squares. And that factors into x plus 2, x minus 2, and of course we have the x plus 3. And there we go. That is a wrap on all of the factoring lessons for the whole year. So I am not going to spring any more factoring lessons on you at all.